Hi everyone, I am Arun. So today we are going to present lab 1, which is 3-phase balanced pure load in star configuration. And these are my teammates Clara, Muhammad Fazli, Lukman Hakim and Muhammad Faiz. So at the end of this experiment or lab section, we are able to demonstrate the theoretical aspect of the operating response of the complex load in an AC and 3-phase power system. And investigate and compare the characteristics of resistive, inductive and capacitive pure individual load in 3-phase balanced load system with star configuration. Before we set up our experiment, our lab, we need equipment such as resistive load, capacitive load, inductive load, power switch module, control 3-phase power supply, which is 0 to 400 volt and 200 ampere and 72 per unit, and power quality meter with display and long-term memory. So I'm going to present the part 1, which is balanced pure resistive load. Let's go to see the procedure. Okay, so the procedure is set up the following circuit as in figure 1. The, the figure that I showed you previous, and connect the resistor in start configuration and set it to level 750 ohm because that's the first resistance we are going to record, and switch on the variable 3-phase power supply and set the phase voltage to 230 voltage. And please do follow the SOP of the lab section. So our first resistor is 750 ohm, and then we reset the resistance to 500 ohm and measure the value again, and then reset to 200 ohm. So we are going to do 3 resistance, which is 750. So as you guys see, all the voltages U1N is 230 volt because we set the phase voltage to 230 voltage, and U12 is slightly different. So for 750 ohm is 396 voltage, in 500 ohm is 397 voltage, and 200 ohm is 399 voltage, which is slightly different. The values are different slightly. So the current is 0.3 ampere, 0.5 ampere and 1.08 ampere. And the power is 69 watt, 117 watt and 250 watt. The reactance power is 0 VAR. For 3 resistance, the reactance power are 0 VAR. And the power total for the resistor at 750 is 207 watt, and power for 500 ohm is 350 watt, and 200 ohm is 747 watt. So as you guys see, the lower the resistance, the higher the power total, as you guys see here. So the reactance power is 0 VAR. For the reactance power total for all the resistance is 0 VAR, and the power factor also is 1 for all the resistance. So my teammates are going to explain further about the calculated value.
I'm Clara Sari and I'm going to show mathematical calculated values for part 1D by using the formula P total equals to 3 times U1N times by current 1 times by cos theta. For the first resistance value, which is 750 ohm, we will insert the value into formula, which will be 3 times 230 volt times by 0.3 ampere cos 1, and then we will get 206.97 watt. Repeat the same step for 500 ohm and 200 ohm, and then we will have value of 344.95 watt and 745.09 watt. Then, compared to the measured values, the value we obtain for mathematical calculated values are almost the same with measured values. So that means our reading are correct. And that's all for part 1D. Thank you.
Assalamualaikum. My name is Muhammad Fazli bin Husin, B081810176 from class S1/2. So for this part 2, balance pure inductive load, for the experiment procedure, first set the following circuit as in figure 2. This one. So this is the result that we got from part 2. We are using formula reactance XL equal to QL over I2N. So for the first one, 1.2 Henry, U1N, we got 3231. For U12, 400, I1 0.66, P1 12, 12, Q1 151, S12 001, PT 25, QT 450, ST 350, cos theta 0.11, and for the XL we got 346.65. And for the 2 Henry, for the U1N we got 231, U12 400, 400, I1 0.39, and the P we got 8, Q 89, S 89. For the P we got 21, Q 265, S 267, cos theta 0.11, and for the XL we got 5 at 5.14. And for the last one, 3.2 Henry. For 2-1N we got 231. For U12 400, and for the I 0.24, 0.24. For the P we got 4, Q 54. For the S 555. For the P we got 17. For the Q we got 164. For the S 165. For the cos theta 0.11. And the last one, XL, we got 97.50. That's all for the part 2 result.
Hello and Assalamualaikum. My name is Umar Hakim and I'm going to present the part 3 balance pure capacitive load. So this is the we're going to do the part 3, the circuit. Okay, experiment procedure. Number 1, set up the following circuit as figure 3. You can see the figure 3 right. And then number 2, connect the capacitive load in star configuration and set it to 2 microfarad, 4 microfarad and 6 microfarad in succession, one after the other. Okay, and the last one is switch on the variable 3-phase power supply and set the phase voltage to 230 volt. Okay, after we set the circuit, we can measure the what we need. Okay, the next slide. Okay, record the following result. Measure the following variable corresponding to the different setting and compute the reactance X of the circuit. Okay, this is the reading after we have measured the what we need. So we can see that the voltage line, voltage phase, I phase, and so many things. P, power, Q, S, and everything. Okay, so for the voltage phase is 230 volt, and same for the different capacitor, and then I phase is increasing. We can see that from 0.5, 0.15, 0.28 and 0.58 according to increasing of the capacitor. Okay, so you can see the measurement there, and then we're gonna measure the reactance using a calculation. So the formula for the reactance is U phase divided by I phase. So the result for 2 microfarad for reactance 1662.50 ohm. For 4 microfarad 831.24 ohm, and for 6 microfarad is 391.55 ohm. Okay, that's all for this slide.
Hi all, I'm Muhammad Faiz. Now I want to share the conclusion from this lab session. In the end of this lab session, we now can demonstrate the theoretical aspect of the operating response of the complex load in an AC and three-phase power system. We also have able to compare the characteristic of the resistive, inductive, and capacitive pure individual load in a three-phase balanced load system with the star configuration. Lastly, we are able to investigate the error that happen while collecting the result and can troubleshoot the problem by referring the theoretical knowledge that we have. Thank you. That's all for our conclusion in this lab session.